Problem 6. The diffusion coefficients for iron and nickel are given at two temperatures. 1273 Kelvin, this value, 1473 Kelvin, you have another value. So determine the values of D naught and the activation energy QD. So what is the magnitude of D at 1100 degrees centigrade? So for part A, we can go ahead by applying this equation. So the equation we can apply is D, which is the diffusion coefficient, is equal to the D naught diffusion pre-exponent is equal to minus QD activation energy divided by K, which is the gas constant, multiplied by the absolute temperature. So K, the gas constant, can be used as 8.31 joule per mole. Joule per mole Kelvin. So for the first data set, we have this diffusion coefficient D is equal to 9.4 into 10 to the power minus 16 is equal to D naught, which we need to find, exponent minus QD we also need to find, divided by the gas constant 8.31 times the temperature is 1273. And for the second data set, we have value of 2.4 into 10 to the power minus 14 is equal to D naught, exponent minus QD divided by gas constant 8.31 into 1473. So we have these two equations. If you can solve it like this, maybe you can divide this equation by the first equation by the second equation. So in this case, you will get a value when you will divide 9.4 into 10 to the power minus 16 with 2.4 into 10 to the power minus 14. You will get 0.03916. D naught will cancel with G naught, and then it will be a ratio of two exponents. So minus QD over 8.31 times 1273. So it is QD over 8.31 times 1273, which is equal to 10,578.6, and then divided by exponent of minus QD over, it will be 12,240.63. So if we simplify this, then it will become like this: 0.03916 exponent minus QD over 12240.6 equal to exponent minus QD over 10,578.6. So we can get rid of this exponent by taking the log of two sides. So log, it will become log of 0.03916 minus QD over 12,240.6 is equal to minus QD over 10,578.6. So we can further simplify this equation into So because log 0.03916 will be minus 3.24, and then I can take this value over there, and then it will become plus QD over 12240.6 minus QD over 10,578.6. okay, and then it will become if you simplify it, then minus 3.24 equal to minus 1.283 10 to the power minus 5 QD. So from here QD will be equal to QD activation energy will be equal to minus 3.24 divided by minus 1.283 into 10 to the power minus 5. It will be minus will cancel with minus, so it will be around 252,433 joule per mole. So approximately you can see 252,000 joule per mole. So in this way we have found QD. So now we can use this value of QD in any of these two equations to find the value of D naught. So for this, now I can use this first equation, 9.4 into 10 to the power minus 16 equal to D naught exponent. QD is, now we know the value, 252,433 divided by gas constant 8.31 times 1273, which we have already calculated, equal to which was equal to 10,578.6. So from here then D naught will be equal to 9.4 into 10 to the power minus 16 and x divided by this exponent value. So this exponent value will be about 4.331 into 10 to the power minus 11, and then D naught will be 2.17 into 10 to the power minus 5 meter square per second. Okay, so this will be the D naught. For part B, now we have been given the temperature as 1100 degrees centigrade. For part B, the temperature is given as 1100 degrees centigrade, which is equal to, also given as 1373. So simply use this equation to calculate the value of the diffusion coefficient D. So D will be equal to, now we will use this D naught value, 2.17 into 10 to the power minus 5 exponent minus QD 252,433 divided by 8.31 by gas constant in joule per mole Kelvin multiplied by temperature is 1373. So put your calculators to work and then you will get here a value of 5.34 into 10 to the power minus 15 meter square per second. That will be the answer. So we can also solve this question by VMSC website from Wiley. Okay, so we can, let's move to VMSC. Okay, in VMSC you have this diffusion but module. In the diffusion module, then we can click this D naught and QD from experimental data, and here you can put the values of the temperature. So the values of the temperature given were For one data point it was 1273 Kelvin, which I have entered over here, and the diffusion value was given as 9.4 into 10 to the power minus 16. So this can be represented as 9.4 e minus 16. So after this you will click add point. The other value was 1473 Kelvin and the diffusion value was 2.4 into 10 to the power minus 18. So it should be entered at e minus 14. 2.4 into 10 to the power minus 14. Okay, so add this point. So now we have added these 2 points, so we can plot the graph by clicking this plot data. So the values of d naught and qd are here, so which we can see. These are these values we calculated before, so very much nearly those values we got.